Have you ever looked at a machine and felt overwhelmed by its complexity? From intricate factory lines to advanced aircraft, we've built machines that push engineering boundaries. But this complexity can become a double-edged sword. Traditional design approaches can lead to a cascade of problems. This is where functional modularity steps in. Large monolithic structures, while impressive, come with inherent drawbacks. Their sheer size makes them difficult to maintain and upgrade. A problem in one area can quickly snowball, affecting the entire system. This lack of flexibility can lead to prolonged downtime and costly repairs. Downtime translates to significant financial losses and potential disruptions. Functional modularity offers an elegant solution to the challenges posed by complex systems. It's like taking that unwieldy clock and dividing it into smaller, more manageable units. Each unit, or module, performs a specific function independently. These modules are then interconnected to form the complete system. Think of a modern computer. It's composed of modular components like the CPU, RAM, and hard drive. Each module performs a distinct function and they work together seamlessly. If one module malfunctions, you can easily replace it without affecting the others. This modular approach simplifies maintenance, reduces downtime, and allows for easier upgrades. Functional modularity brings order to complexity, making systems easier to understand, manage, and adapt to future needs. Reaping the rewards of modularity. The benefits of modularity extend far beyond simplified maintenance. One significant advantage is increased flexibility in sourcing components. Companies can purchase modules from specialized suppliers. This fosters competition and potentially reduces costs. Imagine a car manufacturer using modular design. They could source the engine, transmission, and infotainment system from different suppliers. This approach allows for greater flexibility and specialized expertise. Modular design facilitates innovation. Companies can easily upgrade individual modules. This ensures systems remain adaptable to evolving technologies and market demands. Section 5. A world of sensors, a modular success story. Let's consider a real-world example to illustrate the power of modularity. Imagine a modern aircraft equipped with a sophisticated sensor system. These sensors monitor various parameters like airspeed, altitude, engine performance, and structural integrity. In a modular design, each type of sensor could be a separate module. If a sensor malfunctions or becomes outdated, technicians can easily replace it without disrupting the entire sensor network. This not only simplifies maintenance, but also allows for the integration of newer, more advanced sensor technologies as they become available. This modular approach ensures that the aircraft's sensor system remains accurate, reliable, and up-to-date, contributing to the overall safety and efficiency of the aircraft. This example highlights how functional modularity enhances maintainability, adaptability, and longevity in complex systems. Section 6. Embracing the future with modularity. In today's rapidly evolving technological landscape, adaptability is key. Functional modularity equips systems with the flexibility needed to keep pace with change. It allows companies to integrate new technologies, respond to shifting market demands, and prolong the lifespan of their products. By embracing modular design principles, we move away from rigid, monolithic structures towards more agile and future-proof systems. This shift is crucial for staying competitive in a world where innovation is constant and technological advancements accelerate at an unprecedented rate. Functional modularity is not just a design choice, it's a strategic advantage. Section 7. The journey toward smarter design. The world of engineering and design is on a constant quest for efficiency, resilience, and adaptability. Functional modularity stands out as a powerful tool in this pursuit. By understanding its principles and embracing its potential, we can unlock greater efficiency, reduce costs, and create systems that are as adaptable as the ever-changing world we live in. This journey towards smarter design requires a shift in perspective, from viewing systems as monolithic entities to seeing them as interconnected yet independent modules working in harmony. As we continue to push the boundaries of technology, embracing functional modularity will be essential in building a future where complex systems are no longer synonymous with complexity in management, maintenance, and progress.